Today we're going to take a look at the inverses of trig functions. So first off, let's just recall a little bit about inverse functions. If we have a function f, it's going to take an x value and send it to a y value. And its inverse, f to the negative 1, remember that's our notation for f inverse, has the opposite action. It takes y and sends it to x. And now in terms of a trig function, so let's consider a trig function. How about sine? Well, sine takes an angle and sends it to a real number y. And so its inverse, sine inverse, is going to do the opposite. It's going to take y and it's going to send it to the angle theta. So let's look at an example. Let's evaluate about sine inverse of 1. Okay, so our answer here, again, it's going to be an angle. So we have to think of an angle where we get a sine value of 1, or in other words, on the unit circle, we should have a y-coordinate of 1. And we can notice, well, that's the top of our circle. Here we have the point 0, 1, and so sine of this angle is equal to 1. And what is this angle? This is in degrees, 90 degrees, or in radians, this would be pi over 2. And so that's our answer. Let's try another example. How about sine inverse of square root of 2 divided by 2. Okay, so again, our job is to figure out what is this angle. So for which angle is sine equal to root 2 over 2? Oh, and if we remember, that's the middle angle in our first quadrant, pi over 4, because we notice at this point, our y-coordinate is root 2 over 2. Oh, but we actually have another angle over here in the second quadrant where the y value is also positive root 2 over 2. And this angle here, middle angle in the second quadrant, is 3 pi over 4. So now we have to decide, well, which of these angles is going to be our answer? Because after all, this is a function. We're only allowed to have one output. And so it turns out we're going to use this guy, pi over 4, as our answer. And so now why did we use pi over 4 instead of 3 pi over 4? Well, it all has to do with how we define sine inverse. And in order to even define sine inverse, well, it's the inverse of our sine function, but our original sine function needs to be 1-to-1. And so if we take a look at our original function, f of theta is equal to sine of theta, let's see if we can figure out an interval on which it is 1-to-1. So if I were to sketch this graph, so here's my sine wave. Notice we start at 0, 0, and we're going to get one full cycle from 0 to 2 pi. Right in the middle here, this would be pi. I could even go in the negative direction. I would get something like that. Right? This right here would be negative pi. Okay. And there's my sine wave. And now let's see if we can come up with an interval on which it's 1-to-1. And again, a function graphically is 1-to-1 when it passes the horizontal line test. And so we can consider different intervals, like for example, what if I look at the interval from 0 to 2 pi? Is our function 1-to-1 here? No, it fails the horizontal line test. Okay, let's see, what if we look at, what about this interval? So if we look within this window, notice within this window, our function is 1-to-1. It passes the horizontal line test. And so, well, what is this interval? Well, let's see. This theta value is negative pi over 2. This guy over here is positive pi over 2. And so this tells us that our sine function is 1-to-1 on the interval negative pi over 2 to positive pi over 2. Or in degrees, that would be negative 90 degrees to positive 90 degrees. And, what does this mean? Well, if this is the interval on which our original function is 1-to-1, that means that the range, the kind of theta values we're going to get out for the inverse function, are going to be values between negative pi over 2 to positive pi over 2. Kind of visually, what this means is our angles that we're going to get are basically on the right-hand side of the unit circle. So between negative pi over 2 and positive pi over 2. Okay, let's look at another example. How about sine inverse of 0? Okay, so we're looking for the angle where sine is equal to 0, so our y-coordinate should be 0. And let's see, on our unit circle, notice we actually have 2 points where we get a y-coordinate of 0. Over here on the right, this is 1, 0. Over here on the left, we get negative 1, 0. In both these points, the y-coordinate is 0. And what are these angles? Well, over here we have 0 degrees. Over here we have 180 degrees. But when we go to choose our answer, remember our angle needs to be between negative 90 to positive 90 degrees. So that means we're not going to use 180 because that's outside of my interval. It's bigger than 90 degrees. Instead, we want to use 0 degrees. Now, technically, I could also describe this same angle over here as 360 degrees, right? Because these guys are coterminal. But again, 360 degrees is not within the interval that I want, right? It's larger than 90 degrees. So we're not going to describe our angle that way. Instead, we're going to use 0 degrees, or in radians, this would just be 0. Okay, so either one of these answers. And let's just try one more example. How about sine inverse of negative 1/2? All right, so let's search for this angle. And again, the angles that we have to choose from are going to be from the right-hand side of our unit circle. So between negative pi over 2 to pi over 2. And well, when is sine equal to negative 1/2? Well, I know that's going to be down here in the fourth quadrant. And I believe it's going to be this angle here where the y-coordinate is the smaller guy, negative 1/2. So what angle is this? This is negative pi over 6. Notice I don't describe it as, another way to describe the same angle would be 11 pi over 6. But again, that is not within the interval that I want, which is negative pi over 2 to pi over 2. So I want to make sure and describe my angle this way as negative pi over 6. And there we go.